So it should probably be okay. My name is Dirk Lemmermann, and I've been invited by this Java user group, and especially by PSI, to give a talk about JavaFX technology. And last year's Java 1 in San Francisco, I was giving 3 talks on this topic, and each one of them lasts 1 hour. So now I'm trying to do everything in 2 hours, and so you will hear a lot about JavaFX. These are the topics. So first I will talk a little bit about JavaFX versus Swing. I will compare the 2 technologies based on a framework that I've written for many, many years called FlexGantt. It's a UI control for creating Gantt charts, schedules for planning and scheduling applications. So I will compare JavaFX and Swing based on that framework. Then I will show 10 to 11 real-world applications, bigger applications that were written with JavaFX over the last 2 years. And I will conclude with a set of tips and tricks, things you should consider when working with JavaFX. So let's start with the first presentation called It Gets Better, Developing Frameworks in JavaFX versus Swing. And before I do that, I'm really curious, how many of you are already working with JavaFX? Hey, that's a perfect crowd. Okay, how many have been working with Swing? How many are still working with Swing? I'm sorry to hear.
Personal.
And actually, I was asking the same questions at Java 1, and then I said, oh, I'm sorry to hear that. And a lot of people were like, but we have no choice. They make us use it, and what can we do? Anyway, so I do this comparison, and then I hope you have a few things to look forward to. On the web, you can find me at dlsc.com, Dirk Lemmermann Software and Consulting. I'm located in Zurich, in Switzerland. And this is my website. And on the website, I'm writing a blog on JavaFX. I'm sorry, this is only VGA, so these are high-res screenshots, but they're hard to read. But I'm writing a blog on JavaFX with tips and tricks, and also a blog on real-world applications. And every couple of months, I try to add a little bit of content to it. I'm also developing commercial frameworks. One is called CalendarFX, and I don't know how many are using an Apple Macintosh. Not so popular in Poland. But it's a calendar framework, and if you used Macintosh, you would know that this now looks exactly like the Apple calendar, at least the one that was shipping with Mac OS 2 or 3 releases ago. So I was trying to come up with a product. I didn't want to do the design myself for this framework because I'm not a designer, I'm a programmer. I'm not very good at it. Like most software developers, I'm not very good with designs, right? So I said I would just try to mimic the application that Apple has written because they are really good at what they're doing. So this is CalendarFX, a commercial framework, and the second one is called FlexGanttFX, which is a framework for creating Gantt charts or schedules in general for production planning and scheduling systems. And that's why I'm in contact with the guys from PSI, because they have a very strong need for a control like that. I'm not only doing commercial frameworks. Whenever I write a little control where I think that this control is not really essential for my commercial frameworks, I try to contribute them to the open source community. And I've committed this set of controls to the ControlsFX project, which is the most popular open source project for JavaFX. So in there you will find something that's called a popover, hidden sites pane, master detail pane, and so on. And these two, a world map view and a segmented bar control, they are already submitted but waiting for approval. Okay, so in this talk, I will compare Swing and JavaFX. The intended audience are developers that are thinking about switching to JavaFX, and of course developers who want to be reminded of what it used to be like when they had to code with Swing, or they still have to code with Swing. And again, it's based on FlexGantt and FlexGanttFX. So FlexGantt I wrote twice. I wrote it starting in 2006 for Swing, and then I re-implemented it in 2013 for for JavaFX. Okay, so it's the same control with the same use cases based on two different technologies, and that's why I thought it's an ideal candidate to base a comparison on it. So what are Gantt charts? So I got a couple of screenshots here, and I was wondering if you could tell me which technology has been used for this. So is this JavaFX or Swing? Just shout it out.
Swing.
All right. What gives it away?
The look and feel of the UI.
Yeah, and that uses a couple of user properties provided by Apple, so it has a little bit of a Macintosh look and feel to it. But this is something that you currently cannot do with JavaFX. So this is clearly Swing. This one is JavaFX or Swing?
Well, probably FX by elimination.
But it's you can see that it has a lot of styling to it. Okay, it looks very stylish, it looks very polished, and has this flat look and a modern look to it. Actually, the resolution is really, really bad. It looks really good in high resolution. Okay?
We'll take your word for it.
Thank you. But this is JavaFX. Yes, this is one of my customers, Emirates Airlines in Dubai. Next one. Okay, the Windows XP frame decoration gives it away, right? So this is old, this is Swing.
No.
And? It's Swing and? One more. SWT, Eclipse RCP application. So it's Swing embedded inside SWT and Eclipse. And this is, you can tell again, has been nicely styled and polished, so this is JavaFX. So these are all Gantt charts, and the Gantt chart always has this timeline here at the top, and it has some kind of resources or orders, tasks on the left-hand side, on the y-axis. X-axis is always the time, and then you have some activities that are being displayed underneath the timeline. And one more application, obviously our host today, PSI, and I have a little video of their application that they provided to me. Here they have a resource over-allocation of a resource. I just let this go a little bit. This is completely written in JavaFX, so not just the Gantt chart, but the entire UI is JavaFX. Here they use FlexGantt, but they highly customized it, so it looks completely different than the other Gantt charts we've seen so far. And what they're trying to do in this video is they try to reduce the resource over-allocation that we saw earlier. Different types of charts, histograms, a lot of tables, resizing, drag and drop going on. So it's a very rich UI, and this is something you can do with JavaFX. And one of the reasons PSI decided to go with rich client technology instead of HTML, HTML5 is because they have a very complex business logic in the client, and they have a lot of data, okay? And they want the user to work with the data directly in the client without doing any round trips. If you have a lot of data, like in the gigabytes, you don't really want to use a web application for that and load all of that into your browser. And over-allocation resolved. Hey, everybody happy? All right, so let's take a look back at the past. Now, Swing was introduced in 1997, and in the beginning it shipped as an external library, and it has then become an integral part of Java 2 since 1998. And I don't know if you remember, but in the beginning, all the applications that used it looked like this. This was the cross-platform look and feel. And I remember seeing it for the first time in '96, and I thought, whoa, this looks really good. I changed my mind, and progress has been made, and I think this is not something you can sell to any customer anymore. Okay, this looks rubbish nowadays. Okay, however, it was possible to come up with really good-looking and sexy UIs even with Swing. Okay, there was this demo, this proof of concept software or application called Arith, done by a couple of guys from Sun Microsystem, Scott Violet and Ronan Guy. And they did a really good job. So you see you see gradients and you see reflections, probably drop shadows somewhere, things like that. So modern stuff. And this looks really nice, but The only way you could really do something like that is if you bought this book and you read it, called Filthy Rich Clients. And this was sort of a game changer, because all of these features, all these coolness was already there in Swing, but nobody knew how to use it because it was too complicated. Okay? But in this book, they explained it very well, and then all of a sudden, applications started to pop up that looked a little bit better. But it was really only because these guys sat down and wrote a book about it and open sourced the code of the example code for it. So you could do that. But if you now look inside this book, this is the content of the book. I marked everything in red that you don't need to read about anymore, because nowadays with JavaFX you get all of these things for free, or you just have to call one method or set one effect on a component in your UI, and you get all of that for free. You don't have to read about it anymore. And that's why nowadays with JavaFX it's a whole lot easier to come up with a good looking sexy UI. The second absolutely essential book back then was called Swing Hacks. And those were really, really hacks. I mean, if you implemented them, you really didn't know if they would still work with the next release of Java. Okay, so really hacks, some of them. But here I did the same thing. I marked everything in red, where I just know that with JavaFX you don't need any hacking, or you don't need to read about it. It's just there. You get it out of the box. Yeah. So what is it that JavaFX delivers? I split it up into 4 categories. So I mean, this is basically what I'm saying, and I hope you can take my word for it. What I'm saying is that with JavaFX, it really increases your productivity. You get better styling options, you get higher performance, and you gain improved extensibility. So let's take a look at increased productivity. You get increased productivities in all of these areas. You get better controls. Now, the next one, date and time API, is not part of JavaFX, but because I'm comparing Gantt charts with each other, I thought it's important to mention this too, because this was a big game changer for me, because it made my life a whole lot easier writing the second Gantt chart. And you get properties, observable collections, you get CSS and animation support. Let's start with controls. I created this list with all the controls that you can find in Swing and in JavaFX, and you can see that for every control here in Swing, you get the same controls in JavaFX. But the good thing is you no longer have to type J in front of everything. Okay, so the code becomes more readable, and you have to type one character less, so right away you're more productive. Right? Up to the point where you get to, where is it? I don't know. When you get to JTable, it's actually now table view, so it's longer. Right? So second page of this table, you can see that there's something in green. That means we have some progress here, because and we have progress on the progress bar, which is funny. So far we only had a progress bar. Now we have a progress bar and a progress indicator, because nowadays you want to have that round little animations that save space on the screen. And what you don't have is a JEditor pane or an HTML pane. So in Swing, you had all these nice controls giving you direct support for rendering at least a subset of HTML. In JavaFX, that unfortunately is missing. So that's a little bit sad, but I'm pretty sure that some third-party library will step in eventually. But then page 3 gets really, really interesting, because now we have a lot of red here in the Swing column, because all of these controls exist in JavaFX, but they did not exist in Swing. So there's now a web view based on the standard, I don't know, what was it called again, WebKit or so. So you get really high-end rendering of web pages, HTML, in your application. You get a tree table view. So far, you only had a table view or a tree view, but not a tree table view. You get a media view that allows you to play back a video. You get a small set of charts, like bar charts, pie charts, line charts. There's something called a menu button, that when you click on the button, it shows your context menu, and so on and so on. So there are a couple of things that you now have at your disposal that you did not have before. Right. So one example now in the context of FlexGantt. This is FlexGanttFX, the JavaFX version, and here you can see that on the left-hand side there's a tree table view, okay, which now exists in JavaFX. In Swing, I had to implement that myself, and I ended up writing, 15 classes, I know because it says so, 15 classes, 10 interfaces, 14,000 lines of code that I had to write just to do that left-hand side of the Gantt chart, which is not really the important part of the Gantt chart. You want the right-hand side with the timeline. So I had to write all of this code, and even more because the model classes are not even listed here. Okay, so all of that I did not have to do anymore in JavaFX. So for me, that meant a big productivity boost, and not just productivity boost, but it also meant that the left-hand side of the table was completely standard, and everybody knows how to code the tree table view when they know how to code in JavaFX. Right? Just a short trip to the date and time API. Now in FlexGantt, I started writing FlexGantt for Swing with Java version 5, and back then even Joda time didn't exist.
Oh god, no. Terrible times.
Terrible times, yes, exactly. I like that. So I only had calendar and date. There was nothing like temporal units. There was no concept of a day, a week, or a month. So I had to create all of that myself. I created classes called time granularity and simple granularity, and also calculations based on time, like a date plus 1 week or a date plus 1 month. All of that did not exist back then. So I had to do all of that myself, and that increased the size of the framework unnecessarily, and everything was non-standard. Now in Java 8, you get a really rich date and time API. So how many people are using Java 8? And how many are still on 7? Now it gets embarrassing. 6? Both? Yeah, you can use the higher number. You don't have to mention that you use 6. It's okay. 5? 5? Nobody, okay. Okay, so now in Java 8, life is really good for me because I have to use this all the time, and I was so happy. So Steve Colburn, who's the author of the Time API, I owe him a beer, big time. Next thing that increases productivity is the Properties API. First, I need water. Right. So normally we would write plain old Java objects like this. So if we have a control, and the control has a field showStart, and then you have a method is showStart and set showStart, then okay, that's nice, very simple. But when you have a control, you want to be able to observe this property if it changes. So in Swing, you had to also fire a property change. Mention the name of the property, and then the old value and the new value. And then the party that listened to these property changes had to write code like this. So this is another control, referencing my control, adding a property change listener to the my control, and then reacting to a change of the property. First checking if the source is actually the other control, the my control, and then checking the property name, and then finally doing something. So a lot of boilerplate code, and you would have to write that over and over again. So not so nice. Now with JavaFX, you get properties that can be bound to each other, they can be observed, and they make it very easy to synchronize the model and the UI. So now you can have a custom control, my control, extending control, and you just introduce a Boolean property like that. You have an accessor method to show to this property, and a getter or an is method, and a setter, set showStart. Right? And if you want to react to changes to it, you can just attach yourself like this. You can say my control, showStart property, add listener, showStart property, bind, checkbox, selected property. So this is very straightforward and much less code than before, and much more readable than before. Did I do something? Oh yeah, and you can do bidirectional binding. So you can, for example, bind a checkbox to another control, and the JavaFX will make sure that these two controls are always in sync with each other. So I just want to show a quick example of the usage of such a property. Ignore the arrows, please. So use the general. No. Why didn't anybody say that I went to CalendarFX and not FlexGanttFX? You're not paying attention.
Resolution.
We can't do
shoot, yes. Okay, I hope you can see this at all. Next. Okay, so this is the Gantt chart now, and this is one row inside the Gantt chart. And inside the Gantt chart, it is possible to lay out these bars, these activities, with different layouts. So here we have sort of a calendar layout. Here we have a chart layout. And depending on where the cursor is going, you get a horizontal cursor line, a green line. And if I go any higher up here, then the line disappears. And there are all kinds of properties or all kinds of conditions that control whether the line would be visible or not. And in Swing, I would need to write tons and tons of lines of code to support just this tiny cursor line. But with the JavaFX property, you can do very, very fancy bindings and property bindings, where in this case, we execute the green part, we evaluate the green part to Boolean whenever any of these properties are changing. Right? So you can have simple property bindings where you just say color property bind to other color property, or you can have very, very complex property bindings like this one. So here, whenever a pressed activity is changing, so the user presses on something, for example, I want the green line to disappear. Okay, this is just one example. Right, so this is just one example for a very complex binding. Then the next thing, observable collections in JavaFX. In Swing, data models were very complex. You had interfaces with many methods. You had an abstract, or you still have an abstract implementation of the interface sometimes. You have a default implementation, and you have a model-specific listener, and you have model-specific events. So you have events for the table view, you have events for the tree view. Everything is control-specific. This is one example. This is the tree model, and you can see it consists of many, many methods up here, and then two methods to add a model-specific listener to it. These models, they also had advantages, so because the models were written against objects. So basically you could take your business objects and maybe add some interface to it, and then you could reuse your objects for the model, which would save you a lot of memory, okay? But at the same time, the interface, this was very generic and not so easy to read, and you had to write a lot of code. And here in the model, you can also see that you needed a model-specific listener. So you had a listener for the tree, one for the table, one for combo box, and so on. And then in the listener interface, again, you had 4 methods that reacted to different types of events. And again, you had a model-specific event object right here. All right, so in FlexGantt, this then looked like this. On the left-hand side, in green, you see the interfaces. The Gantt chart model inherited from an iTree table model, which was also part of FlexGantt. And this inherited from the tree model, which was part of Swing. Then You needed default implementations. There was a default Gantt chart model, inheriting from default tree table model, inheriting from default tree model. So a lot of code, a lot of classes, a lot of interfaces. Okay, this is FlexGantt for Swing, and this control is covered or gets all its data from a Gantt chart model. Inside the Gantt chart model, we get timeline data, activities on the right-hand side. Inside the model, we have a tree table model with data for the tree table. And inside that, we have a tree model. So this is a very complex model to support the Gantt chart. Right. Of course, everything gets better in JavaFX. In JavaFX, all the models are basically observable collections. I don't know, did anybody work with glazed lists in the past? So there was an open source framework that added observability also to Java 7 and Java 6. And these guys work very similar. So observable collections, and there's a single change listener and a single change event. So for example, the list view in JavaFX has a method called getItems that returns an observable list. Table view returns an observable list of items. And each tree item returns a list of children that is again observable. Right? And then the model looks like this, and for FlexGanttFX. An observable list consisting of many rows. And a row is simply this. Okay, it makes heavy use of generics, so it's not so readable, but basically a row always has a parent, and it has a list of children. And so much simpler. And it gets even simpler because we can now use CSS in JavaFX. Now in Swing, if you wanted to customize something, like for example, the table header up here, we wanted to give it a glossy look, okay? Then in Swing, we would implement a custom header renderer, column header renderer. That renderer would use an image, a glossy image, and it would need to load it first in the constructor, and then we override the paint component method, and we draw the glossy image and we stretch it to fill the entire width and height of the column header. So we would need to write all of that in Swing. And in JavaFX, we just do this. We have a style called .columnHeader, and we set a background image, and we tell the image to stretch itself. And that's it. Yeah? So really nice. So CSS gives you styling information outside the code base, which makes it really easy to work with it and also to give it to somebody who's not familiar with the code, but who can just work on CSS. And you get powerful styling options for all kinds of attributes. You can even replace the entire skin of a control in CSS. Text color, fonts, padding, and so on and so on. The typical CSS stuff. And if you work with HTML CSS, then this will all look very familiar to you. Animation support. Basically, I think I'm not saying anything about animation support in Swing because there wasn't any. Okay, there was one open source project called Timing Framework that you could use to do a little bit of animations in Swing, but there really wasn't anything official. So now in JavaFX, you have all kinds of classes and infrastructure to support animations. And I don't want to go into too much detail here. I just want to show one example of an application that I worked on last year. Where we used animations for the login screen, where the user could select between different login options. This is a hospital software, so you could choose if you wanted to do an emergency login, or a room-specific login, or a user-specific login. And you could see that we did some nice little animations just to show the transitions between the different types. So you get that in JavaFX. Okay. Better styling options, talked about that already a little bit, but let's look at it again. In Swing, if you wanted to do styling, I mean, you could get a pluggable look and feel. You could buy it or use an open source pluggable look and feel, and then you would set that, and it would change the look and feel of your entire application. Okay, but there weren't that many look and feel libraries that you could actually use. Okay, there were only a few, and only very few of them were really professional enough that you would say, yes, let's use this and ship that to a customer.
Okay.
And like that bar, we could, if we did it with CSS, we would divide the bar into 4 regions, and each region gets assigned its own style. So the first and the last would be .buffer style, and they would be showing in gray. The conflict would show in red, and the OK part would show in green. Okay, but like I said, that would be too slow, okay, too computational heavy. So instead, what you do, if you run into situations like that, you go and you use the Canvas API that is also included in JavaFX. And Canvas API gives you 2D rendering, just like in Swing, where you have the graphics context, where you could draw rectangles and lines and dots. Okay. So I use a much simpler approach now for FlexGanttFX. I basically copied the concepts found in Swing, and I also added a pluggable renderer concept to FlexGanttFX. So the right-hand side of the Gantt chart, is basically one big canvas, or actually in each row a single canvas, and all the activities inside the canvas are rendered by their own specific renderer, just like Swing was doing it. Right, so, conclusion, Canvas is a very important class. If you work with JavaFX, you should look into that, because it will help you in those situations where you just can't work with CSS because it requires too much time. So, and the good thing is that your Swing graphics know-how, it still applies because the 2D API is still very similar. And if you want to, you can even use a renderer concept like in Swing. Higher performance. Performance obviously is for a Gantt chart control extremely important. JavaFX had very good performance compared to what we were used to, like in Java before, especially before Java 6. You know, when you started a Swing application before Java 6, the window would come up and it would be gray first, and only then the UI would be rendered. But you got some of you work with Java 5, right? Or am I the oldest in the room?
I did.
All right. So there you had that gray box flickering effect in Swing applications. Okay. In Java 8, everything is so much better already, except for the CSS performance. Still, I would say CSS performance is totally okay for most use cases. But for crazy stuff like this one, a friend of mine had that. He, for whatever reason, had to be able to add 3,000 text fields to the scene, to his window. And then he was complaining that it wasn't fast enough. Anyways, but those use cases do actually exist. And HTML, CSS, they have to do exactly the same thing like JavaFX does. But they are so much faster, but that is because the HTML rendering engine and the CSS engine is much more matured and there are like hundreds of people working on this code. And on JavaFX CSS, as far as I know, it's only 1 or 2 guys. So let's be realistic. So the performance of a Gantt chart is basically measured by the speed that you can scroll horizontally or vertically with it. In FlexGantt for Swing, every time you perform the horizontal or vertical scrolling, the code would only redraw whatever has become newly visible. Okay? In FlexGanttFX, it redraws everything all the time when you do horizontal scrolling. When you do vertical scrolling, it only redraws the new rows. So let's visualize this. This is scrolling in Swing, in FlexGantt in Swing. You have one big viewport and you have some content in the Gantt chart, and you scroll like this, then basically the orange area gets redrawn. Okay? And this is an example. This is a proof of concept application I wrote for Emirates Airlines. The application was used for network capacity optimization, but we will see more of that in the next presentation. It's loading data. Right. So let's do some row resizing to get a lot of data in the viewport. Make the viewport even bigger. And now we do scrolling. So whenever we scroll, I don't know, 100 pixels to the left, and a region of 100 pixels will be redrawn. You can see very nice performance. Now in FlexGanttFX, what I'm doing is when you scroll, it really redraws everything. Okay, and there are a couple of technical reasons for that, because you cannot really draw into a canvas in JavaFX, and then next time you draw it, shift the already existing content and redraw the new content. You just cannot do that with the Canvas API. So I had to redraw everything. But even when doing that, the performance is still excellent. So this is not the same proof of concept application, almost the same, based on JavaFX. And you can see this scrolls very smoothly. And I'm redrawing everything every single time. And the reason for this is because the rendering code is much closer to the GPUs and the hardware in JavaFX. Okay, much closer to that. Less software rendering. So they get great performance. And for me, as a framework developer, this is actually very good also, that I can now use this approach, because it makes the code much more stable. It's so much easier to just say redraw everything than trying to find out what exactly it is that I need to redraw.
Do you have a ballpark number? How does it compare in efficiency? Redrawing everything?
I don't know. I would not know how to really measure this. If this gives me 60 frames per second while scrolling, then I'm happy, and I do not ask any further questions. And JavaFX is actually limited at 60. It will not, as far as I know, it will not do more than 60 frames per second.
Okay.
Not 100% sure. Yeah. Right. So really, really nice performance. I just found one use case where the performance is not so good. Currently, I'm working for a customer on a virtual machine, remote from home, and it runs on a server, and I think it does not have direct access to the graphic card. So in this case, and that customer migrates from Swing to JavaFX, they have both Gantt charts. In that case, the Swing version actually scrolls much faster. Yeah. So it does have its advantages too. And improved extensibility, yeah, this is very subjective, but for me as a framework developer, I have the feeling that it's a whole lot easier now to write custom controls for JavaFX in a very consistent way than it was for Swing. In Swing, you would subclass J component to write a custom control, you override paint component. The idea was always that you actually implement your own UI delegate, but nobody ever did, because you were thinking that a UI delegate is only needed if you want to support pluggable look and feels, but nobody cares about my controls, so nobody ever wrote UI delegates. Okay? They required their own model, they required their own event listener, their own event objects, and they did not use generics. In JavaFX, you end up with much cleaner code because you have this nice separation of controls and skin. You always use the same mechanism to observe changes to your control because you now have observable properties and collections. They wrote JavaFX from the beginning with the idea of lambdas and functional interfaces, which gives you nice clean APIs. Styling the rendering code, because now you use CSS, the rendering is outside your control, it's in the CSS, so you don't have to write that code anymore. It is just so much easier to come up with clean custom controls in JavaFX. Alright, that was the first part. Oh, 40 minutes, perfect. Questions so far? Alright.